So far, we've been assuming that the discount rate it's the same thing no matter how long of a period we're talking about. But we know if you go to the bank and you say, "Hey, bank, I want to essentially invest in a 1-year CD," they'll say, "Okay, 1-year CD will give you 2%." And then you're like, "Well, what if we give you the money for 2 years, so you can keep our money locked it in for even longer?" They'll say, "Oh, then we'll give you a little bit more interest because we have more flexibility for 2 years. We don't have to worry about paying you. So instead of giving you 2%, I don't know, we'll give you 7% because we get to keep your money for 2 years." And maybe if you say, "Well, I actually don't even need my money for 10 years, so let me give you the money for 10 years," they'll say, "Oh, 10 years, if we get to keep your money, we'll give you 12%. So in general, and this tends to be the case, although it's not always the case, that the longer that you defer your money, or the longer you lock up the money, the higher an interest rate you get. So the same thing is true when you're doing a discount rate. Oftentimes you want to discount a payment 2 years out by a higher value than something that's only 1 year out. So how do you do that? So let's say the risk-free rate. So if you were to go out and get a government bond, the 1-year rate, let's say that they're only giving you 1%. But let's say that the 2-year rate, they'll give you, they'll give you 5%. So what does that mean? Well, let's take the example. So that means you could take that $100, and essentially lend it to the federal government, and in a year they'll give you 1% on it. So that these are annual rates. So 1%, 1.01 times 100, that's just $101, right? Fair enough. Now your other option is you could lock it in. You could lend it to the federal government for 2 years, not see your money, and they say, "Oh, then we're going to give you 5% a year." So then you're going to go 5% a year. So how much do you end up with in 2 years? Well, remember, this is an annual rate. These are always quoted in annual rates. So if you're getting 5% a year, that's going to be equal to, let's do it on the calculator. That's going to be 100. After 1 year, you're going to get 1.05. And then after 2 years, you're going to get 1.05. Or you could view that as 100 times 1.05 squared. So you'd have $110.25. You'd have $110.25. So you already see, not even doing any present value. This is actually, you can almost view this as a future value calculation. If you take a future value, you already know that this option is better than this option when you have a kind of these varying interest rates. But anyway, the whole topic of this is to talk about present value. So let's do that. So in this circumstance, what is the present value of the $110? Well, actually, what is the present value of the $100? Well, we always know that. That's easy. That is $100. A present value of $100 today is $100. What is the present value of the 110? So we take 110, and we're going to use the 2-year rate and discount twice, right? And that makes sense because essentially you're deferring your money for 2 years. You're not going to get anything even a year from now. So you're deferring your money for 2 years. So you divide it by 1, so it's a 5% rate, 1.05 squared. And then that is equal to, I think that was our first problem, right? So I'll just do it again. 110 divided by 1.05 squared. That's equal to $99.77, right? That was our first problem. And now this one is interesting, right? The $20 you get today, and this is just as a side note, it's very important when you're doing this. When they talk about year 1 or year 0, just make sure, is that today? Is that a year from now? Because if it's a year from now, you'd have to discount it, right, by the 1-year interest rate. If it's today, you don't discount it. So anyway, I clarified that. I was a little ambiguous about that in the last few videos, but I clarified it. The $20 is now. So the present value of something given you today is the value of it. So it's $20 plus $50. Now the $50, what do we use? Do we use the 1-year rate or the 2-year rate? Well, of course, we use the 1-year rate, right? Because you're not deferring the pleasure of that $50 for 2 years. You're actually getting it in 1 year. So plus $50 divided by the 1-year rate divided by 1.01 plus $35 divided by the 2-year rate, but this is an annual rate, so you have to discount it twice, divided by 1.05 squared. And let's get the TI-85 out. See, you get 20 plus 50 divided by 1.01 plus 35 divided by 1.05 squared is equal to $101.25. $101.25. So notice the actual payment streams I did not change in any of the three scenarios. And let me just draw a line between them because it got a little bit messy. So that was scenario 1, this is scenario 2, and this is scenario 3. But in scenario 1, because of we used a 5% discount rate for all, you could say, I don't want to use fancy words, but for all durations out, we used a 5% discount rate. We saw that choice number 1 was the best. But then if the discount rate were to change, if we were to change our assumption, if we had a 2% rate, if for whatever reason we could lend money to the federal government in the form of buying bonds from them, we could lend the federal government 2 years over any time period at 2%, or any time period at 2%, then all of a sudden choice 2 became the best option. And then finally, if we had this kind of, and this is the most realistic scenario, and even though the math is fairly simple, we're actually doing something fairly sophisticated here. When I had a different discount rate for my 1-year out cash flows and my 2-year out cash flows, and it was these exact numbers, I had to play with the numbers to get the right result. Then all of a sudden, choice 3 was the best option. And so, and I'll leave it to you. I want you to think about why this was better for choice 3 than it was for choice 2. And if you really understand that, then you, I think, are starting to have a lot of intuition about present values. And frankly, what we're learning here is a discounted cash flow. Right? What is a discounted cash flow? I'm giving you a stream of cash flows. $20 now, $50 a year from now, $35 in 2 years. And you are essentially discounting them back to get today's present value. So when someone says, oh, I can use Excel to do a discounted cash flow, that's all they're doing. They're making some assumption about the discount rates, and they're just using this fairly, straightforward mathematics to get the present value of those future cash flows. But it's a very powerful technique, because if you were to Excel and you were to say, oh, I have a business, and based on my assumptions, in year 1, right now, this business gives me $20. The next year it's going to give $50. The year after that is $35. And this risk-free is a big assumption. But if it was risk-free, you could discount it like that, and you say, oh, this business is worth, if these are the interest rates, this business is worth $101.25. That's what I'm willing to pay for it, or I'm neutral. If I could get it for $90, that's a good deal for me. That's all a discounted cash flow is. But the big learning from this is how dependent the present value of future payments are on your discount rate assumption. The discount rate assumption is everything in finance, and this is where finance really diverges from a lot of other fields, especially in the sciences. There really is no correct answer. It's all assumption driven. All of these discounted cash flows and all of these models, they're really just to help you understand the dynamics of things. And frankly, and this happens a lot in the real world of finance, if you ever become an analyst in at an investment bank, you'll probably do this yourself. But you can almost justify any present value by picking the right discount rate. And actually, the whole topic of how do you decide on the right discount rate, because we assumed risk-free, right? Everything is risk-free. You're guaranteed these payments. But we know in the real world, if you're investing in pets.com and they tell you that they're going to pay these cash flows to you, that's not risk-free. There's some risk implicit in that. So actually, most of finance and most of and portfolio theory and modern finance is based on figuring out that discount rate. And that is the crux of everything, because as we see, that completely changes which of these options is the best. But anyway, I don't want to confuse you too much. What you have already is a very powerful tool that if you can think of a discount rate, you can make a very rational comparison between 3 or 10 or whatever different types of payments. And this is actually really useful. You don't realize how many things in the world are like this, right? You could, these college college payment schemes where you pay some company, $25 a year for 20 years, and then in year 21 they're willing to pay for your college tuition or your kid's college tuition. You could figure out what that really is worth. How much money are they making off of you by taking a discounted cash flow? And of course, if you're paying out, these become negative numbers, and when they pay you, it becomes a positive number. Anyway, maybe I'll do that in a couple of videos, because I think it's a fairly useful thing to be able to analyze. See you in the next video.